Hi, the doctor's in. I'm Dr. LB, and I'm here to help you through your math difficulties. Today, we look at graphing inequalities in two variables. So with graphing inequalities, you want to replace the inequality with an equal sign and graph the resulting equation. Use a solid line for less than or equal to or greater than or equal to, and a dashed line for strictly greater than or strictly less than. Then you want to choose a test point that's not on the graph, and you want to substitute that into the inequality. If you get a true statement back, you shade the region that contains that test point. If you get a false statement back, then you want to shade the region not containing that test point. Let's look at a few examples. Here we have 2x minus y is greater than 4. So because this is strictly greater than, we're going to have a dashed line when we get ready to graph. So let's look at 2x minus y equals 4. Now this is a straight line, so we need 2 points to graph a straight line. So we're going to find the x and y intercepts. If I let x equal 0, then I have negative y equals 4, or y equals negative 4. So I have a point 0, negative 4. If I let y equal 0, I have 2x equals 4, or x equals 2, so I have a point 2, comma 0. So let's graph that dashed line. So we have 2, 0, 0, negative 4. And now we need to test. So let's pick 0, 0. I always pick 0, 0 unless 0, 0 is on the graph because it's just easier. So let's test the point 0, 0. So when I do that, I have 2 times 0, which is 0, minus 0, which is 0. I have 0 is greater than 4. This is a false statement. So when you have a false statement, that means that you're going to shade in the region not containing 0. So we're going to shade in this region on the opposite side of 0 on that line. Okay, so we're going to shade all of this region. All right, let's look at another one. Now we have x squared plus y squared is greater than or equal to 36. So here we're going to have a solid boundary around this graph. If we look at x squared plus y squared equals 36, this is a circle with center 0, 0 and radius 6. So center 0, 0, 0, 0, radius 6. So we're going to go out from 0, 0, 6 up, 6 down, 6 right, 6 left. It's a a solid line or a solid boundary. So this is our circle. And we need to determine whether we're going to shade inside or outside the circle. So again, 0, 0 is not on the boundary of that circle. So let's test 0, 0. So I have 0 squared plus 0 squared, which is 0. 0 is greater than or equal to 36. This is a false statement, which means we're going to shade outside of the circle. So all this region in all 4 quadrants outside of the circle. Now, if you're using any of the computer-aided systems to do homework, Sometimes the shading goes a lot quicker if you have to shade. Sometimes you may have to pick the correct graph from a list of multiple choice graphs. But anyway, all of this around the outside of the circle is shaded. Let's look at another one. We have y is less than x squared minus 4. Again, this is going to be a dashed line, strictly greater than. Let's look at y equals x squared minus 4. Now this is a parabola that is 4 units down from the origin. It's going to cross the x-axis at 2 and negative 2. You can find the x-intercepts if you want to. And then this is a parabola, so, and it's dashed, so we're going to look something like that. So again, 0, 0 is not on the boundary. So let's test 0, 0. We have 0 is less than negative 4, which again is a false statement. So I'm going to shade outside of the region where 0, 0 is located. So all this region gets shaded. All right. So remember that Dr. LB is always in. Please come back for more math help.